Yeah. So as part of our yesterday's session, we completed typecasting. So what is the concept of typecasting and how we are achieving typecasting with respect to uh, smaller data types and larger data types. So with respect to size point of view, especially primitives, we know the predefined values and predefined size, predefined memory, all this. So the size and all we are very clear with primitives. So that's why we can say like which is a smaller one, which is a larger one data type like that. So we know how to do that when we understood what is the point of implicit casting or widening. So nothing but when you are moving smaller data type value to larger data type value level, nothing will happen. So it's a very straightforward operation. But when it comes to the larger data type, if you are making as part of the keeping inside the smaller data type reference level, then only you have to do some casting. So you have to do some explicit casting, like you have to use this syntax always. Whatever the value you are trying to keep, the larger value, and then whatever the smaller data type you are having, the target data type that you have to define as part of the parenthesis braces. So same formula applicable for non-primitives also, but when it comes to the non-primitives point of view, we cannot say like which object is a big object, which object is a small object. When you are having two objects, we cannot say like which is a big one, which is a small one. So but how do we measure, like in between non-primitives point of view? Here it is, it's all only with respect to what inheritance point of view. So as part of inheritance, you have a concept of child and parent. So here, yes, child versus parent point of view, the moment you are having inheritance relation, yes, so you can say like child is the smaller when comparing with the parent. Because of only inheritance relation, I can say that. Otherwise, we cannot say like two objects are equal, or maybe which is a small one, which is a bigger one, or point of view, we cannot say that. But when you are having inheritance relation between the classes, then you can do the typecasting, you can involve the typecasting. So here child becomes as a smaller and parent becomes as a larger point of view, so that you can keep child reference inside the parent as an implicit casting or widening casting. But whenever the moment you are converting that superclass, from the superclass reference you are bringing out the actual subclass object, again you have to go with this syntax. That is what we understood yesterday. So we can keep child class reference inside the superclass, and whenever we are extracting again the same subclass object from the superclass reference, we have to follow this rule. So this is what we understood in the yesterday session. So continuation to this, just one small point, I'll have a discussion and then we'll move to the next topic. Just 1 or 2 minutes point of view, I'll take a small discussion. The reason is, I think I forgot to take yesterday. I'll just take right away. Yeah, just continuation to the typecasting. Now, for example, if I'm taking a new class, let me take a new class, whatever it is. Typecasting data something. Okay. So the moment I take in type, okay, so let me take a class also, a simple class I'll define, like student or whatever it is. So here, assume I have a class called a student class. Okay, fine. And here what I'm doing, object. So is this correct or not? First let's analyze it. Object obj equal to new student. So now is it correct or not? My question is this correct or not? So if correct, why? If why, how it is correct? The point is what here it is. What is the points we have to know? Two things we should know from this line. One is point number one, superclass referring subclass instance. Superclass referring subclass instance. And second point is here, even though student class or any other class not inherited any other classes, but you know that Object is always a topmost superclass. Object is superclass for any class. For any class. That point we know that. So that is the reason this line is true. That means this is a valid line. So if you observe here, student is the class not extending or inheriting anything else. Okay. But as an individual, every class directly or indirectly a parent, I mean child to the object class. That is what we understood in the object point of view. So that's the reason if I'm enabling this line, you will not get any compile time error. So what you are doing here, implicit casting. Implicit casting. So widening casting, okay, or upcasting. So that means smaller data type or child object you are referring to the parent, right? Now, if I want to again same process what we discussed yesterday. So I want to execute student methods. So for example, assume there is a method public void get student info. Some method is there, and then you want to execute this method. Okay, so I mean something body, you define some body and all. My question, I mean my point here it is, I want to call this method. So what you have to do, can we call directly like calling method of student class? So is it possible directly? Means no, we discussed this point yesterday and earlier also. So whenever we are calling a method, like the moment you are superclass referring subclass object, then if you want to call a method, that class must and should present in the superclass level. Must and should. And the same method sometimes may available in the subclass also. If it is available in the subclass, then priority given to the subclass. But if it is not available in the subclass, then it will give priority given to the superclass. But the rule is that method should be presented in both the classes, like should be overridden in the child class. So that is what the rule. So that's why you cannot call that method. Why? The reason is what? This is the method. This is the method is available only in the student class, not in the object class. So that's why you can't call directly like this. Even though your student object is referred by the parent reference object, you cannot call it because this is a private, this is the method belongs to the student class. And this method is not implemented in the superclass. So it's not available in the superclass, only available in child class. So that's why you cannot call with the superclass reference. So in such case, what you have to do? Again, you have to do the downcasting. So downcasting means yesterday same thing we did. Only thing is today I just involved object, that's all. So yesterday we discussed it purely versus class extended point of view. Today I just thought of involving one example with respect to object also, because I'll tell you why I taken this example simple perspective. Now the moment you are doing the downcasting, what you have to do, that means you are making, you are extracting the real object of student from the superclass reference and again storing it back to the same data type. So whatever the object data type student, so that's why I'm taking like student something reference or whatever it is equal to. So you're doing what? Direct assignment is not possible. So if you observe here, directly you are assigning back to the student. So here parent reference, child reference. So the moment your idea here it is from the parent, inside parent, whatever the child class object is there, that reference you are pointing to the real data type of child class only. Actually it is student only, student data type object only. And you are trying to keep put as part of the student only. But only thing is you cannot do it directly. So here you have to do explicit casting target type. So target type you have to define always parenthesis, and what is the target type? So student data type. So you have to do this extra process here. So now what happened automatically? The real student object from this object reference is pointed to the student. Now it's an individual student object. Now what? Now this is, now whatever the reference you are having right now, the variable object reference, now it is directly pointing to the student object this time. So now you can call the functionalities of student class, get student information, something like that. So earlier you are not able to do that because object, I mean parent reference you are having. So that's why you can't do that. So now you can call the methods. So why I taken this point is generally most of the frameworks, when you are working with the frameworks going further, so what will happen internally, they will follow some design patterns, some factory methods, whatever it is, some concept they will follow. And the moment, assume the framework is created some object for a class on behalf of the developer, and that object is returned back to the logic level or wherever you want, that object is always giving by the internal framework implementation is giving an object to you. And then the moment whenever they are giving, most sometimes what they will do is they will give in the form of object reference. So it's a some class or some other class object, some other class object. But what they will do is they will keep this object because what is the target type they don't know. So that's why what they will do is they'll hold this as part of the object reference, object data type. So they will tell you, if you are calling so and so xyz method, the method return type is object. Okay, so even though it is a different class object, reference is object. So then what you will get is you will get always this one. But in the object data type reference level, you are having some other xyz class object. So then what you will do is in our programming again, what you will do is we will do some casting again. So what we will do is we will do the casting like xyz. So like that you will do casting from that reference, and then finally you will get xyz object again. The real xyz object you will have in your logic level. So like this you will do the typecasting. So the xyz class object, xyz class object is being kept as part of the object reference, and that is what written to someone else, and they are doing again typecasting, and they are extracted real xyz object. So nothing but what happened in this case is the real xyz object, whatever we discussed right now, right? So that is the object will come out here. So like that. So that's why I just taken this point. So that means in future you can keep any object directly inside the object reference. When you want to pass, when you want to pass that reference to some other methods level, some other class methods level. Okay, then if you want to transfer an object from one method to another method point of view, sometimes, not every time. So if you, I mean, and assume one more thing I told you already. Assume you have a method called as ABC method, and here you don't know at what time which method, which object will come. Assume you are having classes of ONE1. I mean, I'm just taking in a number format, 2, 3, 4 classes I have. Now, out of these four classes, you can create four types of objects. Okay, that's okay. And you don't know ABC method will receive at what time what object. I want to generalize it. I want to generalize it. So what you can do when you are defining the ABC method, how you are going to generalize. So if you define like ABC of 1, ABC of ONU1, what will happen? It will accept only one class type object. Then 2, 3, 4 type objects, no, it will not allow you. 2 you given only 2, 3 only 3. But if I define my method argument as object type, then what will happen? Yes. Now ABC method is ready to take any kind of object. Any kind of object. You can pass 1, you can pass 2, you can pass 3, you can pass 4, you can pass student, you can pass product, you can pass order, anything you can pass. Why? It is parent. So that means you are passing child class reference to the parent class reference, child class instance to the parent class reference. Now ABC is the method is capable of taking any object, any class object from Java language. Why? You define directly with object type. So the moment assume now you passed ONU1 object. Okay, so you passed ONU1 object, ONU1 class object. So then how do you know that it is ONU1 class object, or I mean first class object or second class object? How do you know that? So yesterday I said in that kind of scenarios, when you are having more than one objects and you are having some confusion, I said like you have to use what? Instance of operator. So if you are using instance of operator, okay, and followed by something like obj of instance of ONE1, if it is really belongs to ONE1 class object, then it will say true, and based on the true, you have to write your own logic, like casting from object to one and then calling one class methods. Similarly, object instance of two object instance. So you have to take help of instance again in these cases when you're having this kind of scenarios. So these are all things will be asked in interviews, and you'll get a lot of things in the real time scenarios and as well as written exams also. So they will give simply these four classes and they will define a method and they will ask, how can I do? I have a method in the 1, 2, 3, 4 classes, individual methods, and I want to call. I can pass any object at any point of time. My logic should work. So how will you implement it? So this requirement I'll ask in interviews also. So I'll ask like simply I'll give, I have four classes and let's take a method, define a method, and that method should accept every time any object. That method should accept any object. Okay, and at the same time I have to call each and every, I mean, I have to call methods of class based on the object what I passed. Then you have to write this entire logic. Checking instance of one, so object instance of two. If yes, then typecast and then call the methods. Like that, you have to do all this functionality. So this is how things will happen, and that's why I taken these things. Okay, so this is all about the typecasting point of view. Especially, you have to know one thing is you can pass any object references. I mean, any objects to the object references also. And the moment you are again doing, you have to do the typecasting only, explicit casting. You have to do that. It's not about only purely inheritance point of view. Sometimes a class doesn't have inherited from any other class. But even though you know that, if a class doesn't inherit, it means it is inherited from the object, directly or indirect. So that's why you can keep student object inside the objects like that. So that's why I taken this example. So you can keep any objects as part of object references. So going further, sometimes we may see some child class object being kept as part of the object. The moment you got object as object type, and you know inside that which class object is available, then you have to do this kind of typecasting. So this point please remember, it's a very important point. Why I taken specially is tomorrow when you are learning Spring also same thing will be available. So the Spring will give you some kind of student object, but as part of the object reference they will give. So then you have to do typecasting and you have to extract respective objects from the object references like that. So that's why I taken this point. Okay. So let's continue with the new topic. So with this I'm done with typecasting, and it's not like that much easy. Within few minutes you can understand automatically. So make some good practice over there. These are all real time things and very complex things also. Okay, let's come back to the new concept called as static methods and default methods in the interfaces. So it's a new concept. So we will see one by one. Okay, so let's see what is the static and default methods in the inside interfaces. Yeah. So as I given from before Java 7, before 7, Java 7, 7 means, okay, in interfaces, we can define only abstract methods, only abstract methods. So that means at any cost there is no concept of defining a method with body. So that means until Java 7 there is no point, I mean there is no concept of defining method with logic, method with body, I can say simply in our terminology point of view. No concept of defining method with body until Java 7. Until Java 7. So that means you know that even as of now, whatever we learned as part of interfaces also, the moment we are creating interfaces like public interface, something whatever it is, calculator or whatever it is, okay, so car or whatever it is. So what we did, we defined even right now also. I mean, we defined only abstract methods like public, void, car info, something like that. We defined always lot of abstract methods only. So until Java 7, you have to define only abstract methods only. There is no way, there is no any concept available writing somehow directly or indirectly a method with body. There is no concept until Java 7. But from Java 8 onwards, from Java 8 version, you know that from Java 7 to Java 8, there are so many new features added. So that means the way of Java programming language is changed drastically in the Java 8 version onwards. Because of lot of features, they involve so many features in the Java 8. There is a huge change happened from 7 to 8, guys. Lot of change happened. That's why till today also people will call Java 8 version. Java 8 version means there is a lot of things happen from 7 to 8 version. Lot of things happen. So that's why Java 8 became a major version. Till today also people used to call Java 8. Java 8 means, that means when comparing with Java 7 to Java 8, lot of things being added newly and lot of new functionalities added, lot of new concept added, lot of so many, the way of programming itself changed from Java 8 onwards. So that's why it's having a lot of importance till today also. People used to call it as Java 8, Java 8. So that is how things are happening. Okay. So that means from Java 8 version, they are allowing to add a concept called as static methods and default methods inside the interfaces. So that means the concept of static and default methods inside the interfaces here, it is nothing but, so that means from Java version 8 onwards, you can along with abstract methods, along with abstract methods, along with abstract methods, we can add default and static methods. We can add static methods and default methods inside the interfaces. So here the moment I said like static methods and default methods means methods with logic. Methods with logic. If methods without logic means, then again it is a concept of abstract only. There is no concept of discussing static and all. So that means the moment I mentioned static and default methods means methods with logic. I think you already know what is a static method. In our classes point of view, when we are learning classes, class will have two types of methods, static methods and non-static methods. So with respect to class point of view, we know what is a static method. So in class, when you are learning class, we understood what non-static versus static method. So if you define a method with static keyword, that method will become as a static method, and then you will call static methods. Static methods are all are part of class, not object. So that's why you will call static methods. You will call static methods. You will call static methods with class name, not object name. So if it is non-static method, then you will call via object names. These are all details we discussed in the classes level. Now, with respect to interfaces also, static methods is same concept, guys. So with respect to interfaces also, static methods wise, 100% is same concept. 100% is similar to classes only. So that means you can define a static method with some logic inside the interface, and you will call those static methods, okay, via interfaces only. So static methods are part of interfaces, and then you can call static methods with the interface name. That's all. Only thing is little bit we have to understand more about default methods. I think we haven't seen as of now a naming called as default methods in classes. Actually in classes, so I'll give you this note also. So note or whatever you can feel. So default methods are not available in classes, guys. Okay. So in classes, there is no concept of default methods. Only interfaces level we have default methods. But when it comes to static methods, yes, what we have seen in the class point of view, whatever we discussed in the static methods point of view, this discussion happened. Same thing 100% is applicable for interfaces perspective also. So if you can define any number of static methods inside an interface, and you will call those static methods by using interface name wherever we want. So it's a simple and straightforward, similar to the classes only. So like nothing but what you will do, you will call like interface name dot the static method name. So if you are whatever the arguments you defined or whatever it is, you will call in such a way. But only thing is little bit different default methods when comparing with the static methods in interfaces. And that too, there is no concept of default methods available in the classes. Default methods is the concept only related to interfaces. Now, what is the agenda behind introducing introducing what is the agenda behind introducing implemented methods inside interfaces? So these are all very topmost interview questions also people will ask. What is the agenda behind introducing implemented methods in interfaces? And sometimes they'll ask one more question like, okay, now assume as part of Java 8 they are allowing implemented methods, fine, whether static or default, that is also okay. Then what was the real difference? What was the real difference between interface and abstract class? See, earlier point of view, what until Java 7. So, until Java 7, definitely there is a difference in between interface and abstract class. Interface point of view and abstract class point of view, there is a difference. What? In interface, you can define only unimplemented methods, non-implemented methods. In abstract class, you can implement, so until Java 7, until JDK 7 or Java 7, whatever it is, same terminology. So as part of interface, 100% you can define only method signatures, non-implemented methods. There is no concept of defining implemented methods. But when it comes to abstract classes, yes, it's up to your choice. Without you can define okay non-implemented methods as well as implemented methods also based on the requirement point of view. Implementation also partial 50% implementation is completed, 50% you left it as a non-implemented, and you made that class as an abstract class. That those are all details we discussed. Then now with respect to Java 8, what these guys are saying with respect to Java 8 point of view, you can define non-implemented methods and implemented methods as part of interface from Java 8. Then what is the difference? Interface, you are able to write non-implemented methods and implemented methods. Even abstract class is also saying same thing, non-implemented methods and implemented methods. Then what is the real difference between abstract class and interface? So with from Java 8 version onwards, So this question is very much popular interview question. They will ask like same thing. Okay, until Java 7 there is a justification. There is no point of allowing non-implement okay implemented methods in the interfaces. But in case your requirement is demanding, few methods are implemented, few methods are non-implemented, then you will go with the concept of abstract class. But here now, interfaces itself allowing implemented methods, then what is the use of using abstract classes? Like that, they will ask this question also. Okay, to get the conclusion about all these things and all, we have to understand concept right away. So see here. First of all, let's see the agenda behind introducing all these things as part of interfaces. Then you got automatically answers for these questions. Okay, so let's see here. Now, why they introduced? For example, see, knowing the concept is important in this case, not writing the logic, because you know how to define the methods. There is nothing to discuss again. What is a static method? Where you have to keep the static keyword? There is nothing. Okay, only thing is knowing the concept. It's not about implementation. So in this specific scenario, we know we written already hundreds of methods. So you don't know, I don't want to teach you again how to write a static method. And what is the abstract method, what is an implemented method, non these are all things already done. So if you are not practicing, it's up to your choice. But I am done from my side. Everything I discussed. Okay, now let's come back. The reason behind introducing these methods as part of Java 8. What is the advantage? What they thought and why they released, why they are allowing to add us implemented methods as part of the interfaces. Definitely there is a challenges, there is a problem until Java 7. So to overcome those problems only, they given these solutions as part of the Java 8. So that means first of all we should know the problem. So what is the problem here? It is until Java 7. See here. It's all again common sense. Okay. So what it is for example, I have an interface called as some interface. Okay, let me take a proper. Okay, so it's an interface, and as part of this interface, assume I have defined some methods and number of methods, abstract methods only until Java 7 point of view I'm talking. So that means I can define only abstract methods and assume I have more than one abstract method, 5, 10, 15, whatever it is. Now, for example, my scenario point of view, I'll take two methods. I'll take two methods. Okay. Mm, which example I can take is, okay. So assume the interface name is banking related, whatever it is. So one method name is something like credit card info, whatever it is. And second one is debit card info, something like that. So these are the high level point of view I'm taking the discussion. These are the methods available as part of the interface. Okay. Credit card and debit card info point of view. I just taken the methods. Now, the moment I have classes implemented from the interface. So how many classes I may have? I can have any number of, right? So assume I have five classes or more than that also. So in this case, the moment I take in class ICICI and then I take in class, okay, so that something like some differentiation I am showing, and these are all implemented from the. Okay, so these are all implemented again from the class called as sorry, interface here. Okay, so the moment any class implemented an interface, what compiler will do? Compiler will ask us providing implementation for every abstract method. So that's why what these two classes done along with, so a class can write its own methods along with implementation of these two methods. 100% every class has to provide implementation for these two methods. For these two methods, every class has to provide implementation. So that's why now every class provided implementation for these two methods. Okay. So it's all implementation. Okay. I'm not writing much details. You know all the things. So provided implementation. Okay. Every class implemented all the methods point of view. Okay, cool. Now after that, these classes may have their own methods also. That is also we know that, and we can create objects for our classes and we can call the methods and all everything. So that means in this case, all five classes, all five classes are implemented, both abstract methods, both abstract methods of an interface. Both abstract methods of an interface with their own logic. That's okay. That is only we discussed in our interfaces and abstract classes point of view at that time. So they can create object for these classes. That's okay. Now after some point of time, your project is working as expected, and they assume this is you implemented in 2020. This project you implemented this logic in year 2020. Your project is going, everything is good. Now all of a sudden today a new requirement came, and that requirement is, so what is my requirement here? It is every bank, every bank, every bank should, every bank should provide some RBI rules to public. So something, some rules are there, or some whatever information is there, some RBI information, something like that. Something, some information has to be, okay, so has to execute, and that has to be printed. Some information has to be printed. So that means now what will happen? Every bank means, so what you will make, for example, if you made again, so to achieve this, that means simply every bank has to print some information. At that information is common information. That information is given by the Reserve Bank of India, assume like that. And that is a common information. Again, in this case, the use case is this. If it is that information is individual to every bank, then again every bank, what you will do? So in that case, you will write again one more, you will add one more abstract method here, third method. So the moment you are adding third abstract method, what will happen? The moment you are adding all, I mean third abstract method, like something void info, whatever it is, I'm just taking point. When the moment you added this method, what will happen? Automatically, all five classes got broken. So what will happen? Automatically, immediately all five classes are broken. Like provide the implementation for abstract method. Like, so that means your broken means you will get a compiled error in all five classes. Like providing implementation of the new method. So that means what is our solution in this case? So as part of Java 7, until Java 7 version, what is your solution? Write, write implementation of this new method in every class, in every class, write implementation of this new method in every class. That is the point here it is. So that means what you have to do is immediately you have to make sure in every class level that new method is being implemented. Like here info, here. So otherwise what will happen? All five, until and unless all five classes are not implemented this abstract method, you will get the compile time error. Why? Because now this time interface is having three abstract methods. So earlier it is having two by default in 2020 point of view, and you implemented and everything is good, compiling execution. All of a sudden today a new requirement came. So that is what comes under the enhancements point of view. So 2025 year something what RBI given some information, and RBI informed to every bank like, so please show this information to the public, and that is a common information, like nothing but assume some guidelines they released, and it is common across all the banks. There is no private information of any bank individually. It's all common law, common thing, some kind of whatever circular or whatever it is. Now this is a common guidelines. Now what's the disadvantage in this case? Assume I said guidelines, right? The moment you provided implementation for this new method, and in Java 7 what happened, I cannot keep these guidelines as part of the, that information whatever I have, I cannot keep as part of the interface. Why? Because abstract methods, I cannot provide an implementation, I cannot provide any implementation, so that's why I cannot keep, I can define only some signature. And the moment you provided implementation for all abstract methods, like this is the solution I said, right? So that means what you are doing is in this case, you are, sorry, yeah, so the moment you return five this abstract method, write implementation of this method in every class. So that means what happens, five times same logic, duplicate logic you return inside the inside classes. So same logic only. I said only a static information, a normal information that is common for every bank. Some loan ranges are changed from repo. So generally you have seen news, right? Repo rates, something like that. So it's a common news across all the banks. But the thing is, even though it is a common data, common logic across all five classes, because of Java 7, and there is no concept of providing implementation inside the interfaces. In the moment I added this method at interface level, all five classes must and should provide implementation for that method, as well as all five classes are provided. But the thing is, you return same logic again as part of all five classes. So what's happening in this case? Because logic is, I mean the logic is same, but you written five times in a perspective of duplicate logic. There is no alternative for us to make it as a single place and all, because the method is added as what, interface level. I added at interface level 100% every class should provide implementation. Okay, if it is a individual logic for every bank, then providing five every bank implementation, its own implementation, there is no problem in that case. But my point is, assume it is a common logic. Why unnecessarily you have to provide same logic in five classes? Five classes. Okay, that is what the problem here it is. Now, for example, assume again until JDK 7 only. Okay, by the time already interface is defined, guys. I'm telling like this you did in the 2020, and today 2025 point of view with respect to JDK 7, I'm asking all these questions. Now assume, okay, JDK 7 only. Assume I said this as a not an interface. I made it as a abstract class. Then what will happen? So assume, this is assumption point of view. Assume instead of interface, if I am using abstract class, What is your solution? Maybe if instead of an interface, if I'm using abstract class, assume it's all assumption, but already assume interface is there, you cannot change it. But in case abstract class is there, what will happen? Abstract class will have implementation also, right? Abstract class methods. So abstract class will allow us to add implementation methods also. And the moment you made abstraction, every class is going to extend inheritance. That means automatically what will happen? Two abstract methods you will provide the implementation, and the one third method, whatever the guidelines you are having, you will provide directly logic in the abstract class. So that means what I'm trying to say here it is, if in case if it is an abstract class, I don't know how many remember the abstract classes, all this thing. Okay, now assume if I made this as a abstract class, some reason, abstract class. So the moment you made abstract class, earlier these two methods are abstract methods only. That's why every class extended. Whenever it is abstract classes, the concept is all about extended, extends. So the moment you extended, what will happen? Every class must and should provide implementation to abstract method. So that's why, okay, cool. Now the moment when it comes to the third thing, third method, whatever I am going to add, and it is a common logic, common information. So in this case, I added it as a non-abstract method. So that means I provided implementation directly in the class itself. So here itself, the third method, whatever I added here, I provided with some that guidelines printed, whatever it is, guidelines, logic I written here itself. So then what is the advantage here it is? So in this case, your answer is immediately all five classes are broken? No. No class is broken. So that means what happened? In this case, no need to provide implementation of that new method. Of that new method. Why? Because it's a implemented class. It's a class. It's an inheritance. The moment you are having this method in the parent class level, child classes can access directly. So the point here it is, child classes can access directly. Child classes can access directly. So that's why you no need to provide implementation for that method again in your class point of view. So this is when if you take an abstract class, but the problem is assume I already have interface. Now I cannot change it as again abstract and all. If with respect to interface perspective itself, if you are having this kind of challenges, what you have to do means you have to write 100% again that same logic in every class level 5 times you have to define. You have to do that. There is no choice until JDK 7. Now this is the problem they identified with respect to interfaces and implemented classes. What it is in the moment implementation is happened, nothing is going to happening. But after some point of time when people are or where any requirement is coming and that requirement is expecting us to provide a common logic across all the implemented classes, then what is the problem happening here it is in every implemented classes level you have to provide same logic every time. That became a challenge. So that's why what these guys did from Java 8 onwards, by taking this kind of reference only. See, whatever the same thing if I taken in the JDK 7 itself as an abstract class, when in the 2020 itself, whatever the thing you taken here, you don't need to provide implementation. But with respect to interfaces point of view, same thing should happen. So that is the reason they came up with the JDK 8 onwards. What they did here it is. So what they did from JDK 8 from onwards here it is. They started allowing implementation methods as part of the interfaces. So that means in interface itself, you can start writing non-abstract methods. So that means you can add a method with a logic. with a logic. So that means the third method, whatever I am talking right away. So assume now it is a Java 8 version and you implemented it in 2020 like this interface 2 methods, and today you got a new requirement like you have to publish the guidelines by every bank application guidelines. So whatever it is. Now it's a common guidelines. That's why what you did in this case today is you added that new functionality in today's logic, as you added a third method, something like guidelines information or whatever it is, and you started giving all the logic here with respect to guidelines. So it's not an abstract method, it's an implemented method, non-abstract method, and you added where this one in the interface. So whether it is a static or default, I'll tell you. So whether it is what, okay. But finally, Java is allowing us to add an implemented method to the interface. Then what will happen? Are you going to automatically your classes are going to be broken? No. Why? When your classes will be broken, when you added an abstract method and you are not implemented, then only compiler will gives us errors. Hey man, please provide implementation to the abstract method. But in this case, you added non-abstract method. You added what? Non-abstract method. The moment you added non-abstract method, you will never get a compile time error like you have to override must and should like that. Same abstract classes, right? So even we when we discussed about abstract classes also, if a class is having two abstract methods and one three non-abstract methods, only compiler will worry about abstract methods. It will never ask us to override the already existing methods. It's up to your choice. Method overriding is your choice. But providing implementation for only abstract methods point of view, compiler will always gives us warning. Compile time error. Hey man, please provide two, please provide two, please provide two, this two methods implementation like that. But if you are having other than those two, if you are having five, six unimplemented, non-abstract methods or implemented methods, compiler will not say anything to you. Compiler will say like I'm okay, but if you want to override you can do it. It's up to your choice, but mandatorily you have to provide implementation for the abstract methods. So same point of view here also, from that is the reference they taken from there only, and they came up with this concept. Now what is the challenge you achieved here? It is you added logic in single place. We added logic in we added logic in single place. We added logic in single place, and automatically the same logic is reflected in all implemented classes by default. In all implemented classes automatically. Reflected in all implemented classes automatically. So, because as a parent, you know that inheritance versus, sorry, interface versus implemented class, I said already it is one kind of inheritance only. So it is inheritance only. Interface versus implemented class means it's inheritance only. I said that point. Even we know one rule also. Interface can refer its implemented class object. Nothing but parent referring child object. So such a way, now you added at parent level with the logic this time. That is the advantage of these static and default methods. So whether it is a stat, and again, what is the difference between static and default with respect to interface? We will discuss that point. But overall point of view, why they are giving is, so you are added that into interface level, then you no need to touch all five classes. One of the classes you don't want to touch. So that means in this case, you no need to provide implementation for all five broken classes, because first of all, you didn't get any compile time error like you have to add implementation for this one so method you are not getting. So that means you no need to worry about again writing the same solution into five methods. So that means when you are not writing means you are avoided the duplicates, and you are not written five times. You written only one place, and automatically all classes can access. Now what will happen in this case? Automatically all classes can access that method also. All classes can access that third method also. Now all five classes. So that means the result is what? Maintenance point of view, as a developer perspective, development perspective, added in one place. Okay, single place logic is available. So you are not added in five places, but being used by five implemented classes. Now assume tomorrow, in a point of view, your class is implemented, sorry, your interface is implemented by 100 implemented classes. Your interface is implemented by 100 implemented classes. Then if you don't have this feature, it's a challenge. Like all the classes level providing implementation, all this headache you have to take care. But today, if you are allowing an implemented methods in the form of either static or default, whatever it is, but what is the real difference between again static and default? We will see that. On an overall perspective, they are allowing static and default implemented methods. So that means you can provide logic at one place and you can access at one place. This is all called as backward compatibility. See, in interviews nowadays, they're asking simply a question like, can you explain what is a backward compatibility? So they will not give hint also. So they will not give hint also. So they will say simply, can you explain what is the concept of backward compatibility like that? So what is the point of backward compatibility here? So to achieve the backward compatibility, this concept came in, I mean, they brought from the Java 8 onwards. So what is a backward compatibility here? So the backward compatibility point of view, if you go to the again old version, see that's what, right? When we are comparing with problems, we will we will identify the real things. So when it comes to JDK 7 point of view, you don't have the backward compatibility. That means what is the point of not having backward compatibility is in 2020 year, based on the requirement, two interface methods are available, two abstract methods available, and you provided all the logic. That's cool. Okay, and you don't have any, and every class is having its own implementation for credit card and debit card functionalities. It's okay. But after some time, it's all about maintenance of the application. In future, the same project is enhancing with a new requirement, and that requirement is saying you have to publish guidelines to every customer by every bank. And here the guidelines, whatever, I mean, I'm taking it as an example, guys. Okay, so the guidelines, whatever I'm saying, and I said again, same thing is that those guidelines, whatever I you want to publish, again common to all five banks. There is no individual private guidelines across all the banks. It's all common guidelines for all the banks. So that means if you are implemented at one place and if you are using five places, it's okay. And at the same time, every class must and should access those guidelines whenever they want and whenever they want to share it. That is point number one. Okay. Now you can say, sir, I will define five abstract methods. Okay, five places. One more challenge I will tell you. You provided until Java 7 what you did, you provided that as an abstract method. Automatically, five classes are implemented. They know their own, I mean, same logic again, guidelines, 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 and they return all the duplicate logic again and again, again. Okay, assume like that. Tomorrow, assume there is a small change in the guidelines. Some changes happen in 2026. Again, those guidelines are updated. Guidelines are updated. Guidelines are updated. So that means what is the problem? The moment guidelines are updated, what is the challenge again here? You have to again update same thing in the five classes. Update in five classes again. In case if there is any change in the guidelines, you have to update in five classes because you provided implemented. But here, if you go to this solution, you added at how many places? One place. If any update happened in 2026, they given some small changes in the guidelines says your updated logic in one place. Your updated logic in one place. Automatically, all below five implemented classes can are able to access always the updated logic only from here. So that means maintenance. You made change in only one place and automatically it is reflecting again at all implemented classes. But here you have to take care again. Every class level you have to update logic based on the new things. That is the challenges here it is. So that means what is the problem here it is backward compatibility means. Now let's understand what is the backward compatibility point of view here it is. The moment you designed your application at the current moment, based on that whatever you implemented, that's okay. But after some point of time, when few things being shared across implemented classes specific to an interface, okay, after some point of time, after 2 years or 3 years, that's why I taken. Assume you implemented in 2020 like this. Today in 2025, you have to do this. Tomorrow next in the January month, you have to do this like that. So that means the moment currently when you are going back and making the things, you are making things at every place. So that means without disturbing these implemented classes, without disturbing these implemented classes, I have to make sure these new things are available automatically to 5 classes. It's not possible if you are using JDK7. So that means you have to disturb your classes. Until and unless you are not disturbing all 5 implemented classes, you cannot compile your code. You cannot achieve your new requirement. So that means here, without touching my, so in this case, without touching my implemented classes, I cannot do anything. That is what you don't have a backward compatibility. What is the point of backward compatibility is in the front end point of view, I mean front end means in a implementation logic execution point of view, these 5 classes are actively working, and without touching these 5 classes, I have to introduce a common logic. So that's not possible until Java 7 with interfaces. So you don't have a backward compatibility. So that means backward means backside to the Java implemented classes. Backward. So if you are going back to the classes implementation and if you are making it a small common level and you are trying to get it into all class level, all implemented classes level, or sharing that into all implemented classes level is not possible with respect to interfaces and its implemented classes point of view. And that logic has to be available for every implemented class automatically. That is not possible in the JDK7 until JDK7. But Java 8 onwards, because of this new methods, what you are doing? Yes, 2025 you got new guidelines. What you did? You added a new method inside the where in the interface. Automatically all classes can access. All classes are able to access. Now in 2026, again some small guidelines changes are going to happen. Then where you update it in one place, automatically all 5 classes can access. In 2027, in 2027 again, assume there is a probability, I mean possibility of adding adding a new functionality across all the bank classes. So that means in such case also, in such case also, what if with respect to Java 8 you are having backward compatibility? What you will do in 2027 based on the new functionality, you will add that new functionality again into interface level. So that means you will add, assume fourth method I am adding. Fourth method I am adding with logic. Automatically what will happen? You are doing the backward compatibility. You added at interface level, then that logic or whatever you added in the interface level in the backside of these classes, those are all compatible to these classes. That's why they used a word called as compatibility. The moment you added something to interface level with logic, the method, it is compatible to every class of that interface, every implemented class of that interface. So that means in 2027 also, you added logic in only one place, but automatically all 5 classes or 100 classes are there. 100 implemented classes are there for this specific interface. Automatically all classes can access that logic from the common place. That is what. Now my next question is, sir, it's okay. You said whatever we are adding with respect to logic of a method in an interface, maybe there is a static or default, that we will understand. uh, Something we are added in the interface point of view, and you are saying that those are all automatically commonly accessible by every class. Now sometimes maybe, okay, the requirement is like this: out of all banks out of all banks, few banks see, my point of view, bank means here classes, five classes are there, few classes. I'm making in a real time terminology point of view. Out of all banks, few banks are, okay, provide guidelines in their own format, in their own format, in their own format. So what is the point I'm trying to say? It is, you added guidelines in a common place, automatically all banks can able to access and they can do it. But sometimes, now assume in this case, SBA class as well as ICICI both decided, like both classes point of view, they want to, okay, provide, they are providing guidelines, okay, they are provide those objects are, those classes are providing a functionality of guidelines, but only thing is they want to add their own things also along with existing logic, existing guidelines point of view, they want to add few more of their own also. But these are all mandatory or whatever it is, some customization they made to the these guidelines, they want to do that, that's all. And remaining banks felt like, okay, Axis, HDFC class, and these three classes felt like, okay, as per mandatory point of view, I'm accessing this logic and I'm able to deliver to whoever want. I can access that logic or whatever it is. The point here it is, now SBI and two classes felt like they don't want the logic what is being added at interface level. They want their own customized logic. In simple point of view, what is my point here? It is, now Java terminology point of view, instead of instead of interface implemented method logic, okay, so class would like to implement its own logic, its own logic. What you have to do is, what you have to do, guys, you know the concept. So when we discussed, when you don't find your parent logic, but in place of that, if you want your own logic, what you will do? What you will do? See, it's all parent child only. So when you don't want parent logic and you want your own logic, then what is the concept we know? Yes, method overriding. That's all. So that means in this case also what you will do is, yeah, you provided implementation here, automatically you have access. But in case if you want your own logic apart from this logic, you have to do method overriding. You have to do what? Method overriding. Method overriding means with same signature providing your own logic. Method overriding. And you know method overriding is always happens with respect to non-static methods, not from the static methods. So you will do method overriding. So that means now SBI and ICICI class, what they will do is, assume they added their own guidelines info method. So they added their own info method. Yes, it's your choice. You have a compatibility. You can do that. Even you are not having a lot of customization. So now SBI provided its own info and all. ICICI also provided its own info method. Its own info method. So that is what the advantage of these classes. But remaining on all, they don't want. They are still accessible from here only. Even these classes also they can access, but they want their own. But in Java 7 point of view, until whether you are having it or not, you don't want to or not, 100% you have to provide implementation everywhere. Everywhere you have to provide implementation of this one. Everywhere you have to write implementation of info like that. So 5 classes. If you are having 10 classes, 10 classes, 10, 15, 15. But here, by default, only one place, automatically all classes can access. So this is the purpose. This is to achieve this kind of backward compatibility. So that's why they are saying backward compatibility. So what is the point of backward compatibility is that is what. So it's all about you are making compatibility of logic with respect to all the implemented classes and with respect to interface level implementation. So without touching, simple, and a simple note I can tell you, without touching all implemented classes, you are making logic is available to all implemented classes without touching all implemented classes, and we are making that logic being available again as part of every class, every implemented class. That is what called as backward compatibility. So to achieve backward compatibility, to achieve this kind of customization, they came up with a concept called as static and default methods. So that means in interface you can define now static and default methods as part of the backward compatibility. Now the point is, okay, finally we understood like some implementation method we are added at interface. It's allowed from the Java 8, and then we can access at classes level. Now why they given again two types of methods? Two types of implementations. Why they provided again two types of implementation methods in interface? On overall we understood as of now, if they are providing implementation at interface level, so that automatically all implemented class. Now again, why they provided two types of implemented methods in interface like static and default. I can give you a small hint here. It is, I said already, static point of view, static is 100% similar to classes concept only. But when it comes to default methods, I mean, in interface first point of view, in default methods are somewhat similar to, okay, here I cannot say similar, exactly same to classes. But here, when it comes to similar to non-static methods, that means instance methods, non-static methods. So that means here, when you will go for static and default methods inside the interfaces, here it is again. So what I will say is, for example, if it is a default methods, so when you will go for the default methods is, so a default method in interface, okay, a default method in interface is nothing but like, so we want to allow, when you want to allow overriding, when you want to achieve overriding in implemented classes, in implemented classes. So a default method in interface, generally when you will go for default methods is, see, finally default method in interface is having a body. That's common. In interface is having logic. That is a common point. That is what we are discussing. Body and all it is having. But when it comes to static methods point of view, let's write static also, then we can understand easily. So static methods point of view also, a static method is having body. That's okay. That's common. But a default method in interface generally when we want to when we will define is when we will in is allowing overriding in implemented classes. So that means generally when you will do the overriding guys, when you define the non-static, I mean if it is Java classes point of view, you know what is the overriding, parent class, child class. Generally method overriding is always happens only with non-static methods because non-static methods are related to the objects. Non-static methods are related to the objects. Non-static methods. And static methods are related to the classes, class area, single global. Okay, so that's why in this case also they thought same thing. To achieve that object oriented solution method overriding point of view, they given default methods. So that means now assume in an interface level you have a default method. Okay, I'll give one more point here. A default method is defined with keyword default. That is in method signature, simply we will add a keyword called as default guys. In method signature, we have to add default. If you are added default word, then it will become default method. If you added a static word in interfaces perspective, a static method is defined with keyword static. That is in method signature we have to add uh, yeah, we have to add static keyword. But without static or without default keyword, you cannot define any method interface. But in Java classes, without if you are added static, that will become static. If you remove static, that will become non-static. But in interfaces, you don't have a concept of non-static methods. You in place of that, we are having they introduced a word called as default, and that you have to use default word. So that's why assume I am adding default something like void info, whatever method it is, like this. So I have logic here. So now this is called as default method. And if you are added in the same so I'll come back. So you can add static. Then it will become static method. Now the point here it is again one more point. We can add n number of static and default methods in a interface. So what is the point you understood here? N number of means you can add more than one static method in case if you want. 0 to n. That means you may have static or default, you may not have. In case if you have, you can define n. N means more than one. In a single interface, you can define more than one static and default methods in case whenever based on your demand, based on your requirement. Even zero also. So that's why I given this point. Okay, now I said a default method in interface when we will define is allowing overriding implemented class. And when you will go for the static methods is okay. A static method in interface when we will define is when we will define is that logic is not accessible by instances. I mean that logic is accessible by commonly all classes without creating an instance. Without creating an instance. of implemented classes. See, these are all points, summary points you have to answer in interviews. Example we will see tomorrow. That's what I said. You know how to write methods, you know everything. So here understanding the problem statement from Java 7 and why they introduced Java 8 backward compatibility. So knowing the concept is more important in today's point of view. So writing static methods, you don't, I don't need to say again. And default method, you know what is a method and all. Only thing is if you add a sorry, default keyword to the method level, then it will become default method. And it will similar to non-static methods. That's what I said. Similar to non-static methods. Generally, we will do non-static methods or overriding. And to do the method overriding, to achieve the polymorphism, you need always object. You need always object. To achieve the polymorphism, to achieve the method overriding, to achieve logic execution of non-static methods, you need always object. Object of a class. But when it comes to static methods, you don't need any object. Generally, what I said when I explained about in the classes point of view. So then also I said, static methods are always accessible by class names. That means no need of object. That is what I said. We discussed in the static and non-static methods in our initial days. Okay, but when it comes to non-static again, scene is reverse. So that means you cannot access non-static methods by class names. You have to accessible by object references always. Object references. So that means 100% is you need of object. So now if you're applying same thing with respect to static and default point of view, that's why I used default is similar to non-static. And in interface when you will define static method is, in case assume your requirement is demanding like without creating an object of implemented class, that logic has to be executed directly, then you can go for the static method. A static method in interface we will define, when we will define is that logic is not, that logic is accessible commonly by all classes without creating an instance, an instances or instance means object of implemented classes. So that means how they are accessing interface. Right now I given somewhere else, I think. Okay, maybe interface name dot static method, you will call like this, simply interface name. But when it comes to default methods, when we will define is, okay, and those methods allowing overriding, I mean, it's like I can extend this point also. We will define accessible, opposite to that, accessible by instance of implemented class, as well as in this case we are allowing overriding also, in case if they want provide their own logic in place of that method. So in such case you will provide the default method. So that means in this case what I said, we will accessible by instance of implemented class. So that means if you have a class here B implements A, so that means in this case how will you access that default method of info is, you have to create object of b equal to new b, and then b dot info. So you are accessing default method of interface only, but you created object for the implemented class and then you are able to access. But if you take in same scenario with respect to static method point of view, so if it is a static method, what I said, to access, if it is a static method, you don't need of object of b. So that means simply you will take interface name a dot info, a dot info. That is one thing. And sometimes you can directly access without implementation also, but generally we won't do that kind of things. Maybe in AD, for example, class C I have. Assume class C is not, in this case, you can access a static method, a interface static methods, but not default method, of a. Why? To access default methods, you need always implementation of that interface. There is a relationship between available like that. In this case, class C doesn't have any relation with A, but still you can access A static methods. Why? To access static methods of an interface, you don't need any object. But actually, to access the default methods, you need implemented class object. But you don't have implementation here. I mean, you are not implementing interface A. That's why you cannot access default methods. But you can access static methods. So these are all points you have to remember. And what I will do is tomorrow, the moment once we connected, we will make an example about default and static methods inside the interfaces. That means whatever the summary we discussed here, whatever the points we discussed today, let me save it first, otherwise we will lose it. Okay, so whatever we discussed today with respect to backward compatibility point of view, we will take interface and some implemented classes, and then we will see how we are accessing default and static methods, whatever we created in the interface, like all these points. Like we will take some extra class without implementation of a, and one class with implementation, or more than one class, and then how you are accessing static methods, how you are accessing default methods, and how you are going to override default methods. So then which method is executing? Is it executing from implemented class, or is it executing from the interface level? So these are all things we will convert into a practical example in tomorrow's session. But I mean, in a overall perspective, theory perspective, we are done with default and static methods. But only thing is we have to convert our entire discussion into practical examples point of view. I'll make it tomorrow. Programming point of view. And there also a couple of things we will discuss. While we are doing the coding, definitely we will see some few more points on top of all what we discussed today. But I am telling you very important concept, and it's very important. And whenever they are asking, do you know Java 8 features? Immediately you can tell one of the feature is default and static methods inside the interfaces. It's all about what is the concept, backward compatibility, achieving backward compatibility, and examples and all. We have an enough discussion here. So if you are taking all this kind of explanation to the panel persons or wherever it is, see, generally this question, whatever I asked, backward compatibility is being mean to an experienced person. So generally experienced people also not able to answer sometimes what is a backward compatibility and how we are achieving. So so that's why just concentrate on here and get knowledge on your own and try to make it. That's all. So any doubts you can ask me, otherwise we can connect on tomorrow with a practical example for this. And then we'll, if you have time, we will move to the new topic. Probably I'll start annotations.